Hi, this class is to talk about inference about means with two populations when you know the population standard deviation. This is based on chapter 10 of our book. And what we are doing in this section of the book, we don't know if two population means differ. So we have two populations, they have different means, we don't know if they really differ. We're going to build confidence intervals for the difference between the two population means. Again, we're going to use sample data, confidence level, and z-scores. Okay. First part, let's understand how to build a confidence interval, what we're talking about. I'm going to skip this slide and go back and come back after I show you an example. Here, home style furniture. This company sells furniture at two stores in Buffalo, New York. One is in the inner city and the other in suburban shopping center. There is difference in the types of furniture sold in each store, and manager believes this can be attributed to the difference in customer demographics. The manager wants to investigate the difference in the mean age of customers who shop at the two stores. So that's a fair problem. That is a common problem. Many companies, they have different stores and they want to know if there are really differences in their stores. Sometimes we simply say, yeah, those customers that buy in the inner city, they are younger, but people that buy in the suburban area, they are older people. But maybe this is based on only some, let's say, perception of people, maybe perception of salespeople, perception of manager. And we have to make sure that they're really different. Here's the example. We have the inner city store, the suburban store, and to make sure they're really different or how different they are, and to build a confidence interval for how different they are, we collected two samples. Sample in the inner city, in the suburban store, 36 customers and 49 customers, and then we have their age. In the inner city, 40 years old. In the suburban store, 35 years old. Standard deviation, 9 years old, and suburban store has 10 years old as standard deviation. So what is the difference in the mean between these two samples? Really, what is the difference? Is it too big? Is it too small? How big this difference is? Okay, so this is what we are doing. So in order to develop an interval of the difference between the two population means, the following sample distribution must be computed. The expected value, the estimator for the difference. So we have to compute how much different these two stores are and compute the standard error for both population. This is the population standard deviation. This is readily known, as we have been talking about, but often a good estimate can be obtained based on historical data or other information. Maybe the company knows, and we're going to refer to this case as the standard deviation, population standard deviation known case. Okay, this is going to be one of the three cases we have. Let's take a look at the sampling distribution. So you see this sample bar 1 minus sample bar 2. This is the sample mean. This is the mean for the first sample. This is the mean for the second sample. So we are measuring the difference between these two samples. Are they really different? Are they similar? So the sampling distribution for the difference is going to be composed of two elements, the expected value and the standard deviation. So the expected value for the difference between these two populations or these two samples is simply the difference between one mean and the other. Okay, that's very simple. You compute the mean for the first sample, you compute the mean for the second sample, you subtract one from another, and then you have an estimator for the difference. And then we have the standard deviation for this difference. The standard deviation for the sample mean difference is going to be equal to the square root of the standard deviation of sample 1 squared divided by the sample size for sample 1 plus the standard deviation of population 2 squared divided by the sample size for population 2. Okay, so what we're using the standard deviation for each one of the populations in order to come up with the standard deviation for the difference between these two samples. Okay, so this is like the formulas we're going to be using. And this is the final formula to compute the interval estimate for the difference. Remember that this confidence interval estimation process is based on the point estimator, in this case, point estimator for the difference between the two populations. We're going to be using the samples to estimate the difference between the two populations. So this is the estimator, and we add and subtract a margin of error. This margin of error is based on the standard deviation for the difference, which is given by this formula, multiplied by a confidence level. You know all this, okay? And the alpha is where 1 minus the alpha is the confidence coefficient, okay? So we have been through this in chapter 8. So now what we're doing is we're adding a second sample and a second standard deviation in order to obtain. Going back to the slide that I skipped, so this is more theoretical. So let's assume we let the mean for population 1 equal the mean of population 1, and this is the mean of population 2. The difference between the two population means is given by the difference. We subtract one from another. To estimate this difference, we select a sample of size n1 from population 1, and we select a sample of size n2 from population 2. So we are selecting two samples, and then we let x bar 1 be the sample mean for sample 1, and x bar 2 be the sample mean of sample 2. Okay, and then we have the estimator, which is the difference which I just showed you. Okay, so I'm going to stop here, and I'm going to work on solving this problem in the next slide.